All right. Quick question. I know some people in here know Terraform pretty well now. Who's never touched it and never used it? So everybody's total master of Terraform. Cool.
It's like two extremes there.
Yeah. Well, you know, I mean, obviously, if you've never touched it, you're not a master of it. But once you've used it once, it's you know, you've got total domination of the whole tool set. No sarcasm included there at all.
Minus learning seems legit.
Exactly. It's minus learning. Exactly. So, what I'm going to talk about is very specific use cases and workflow around Terraform and Packer that I was mostly involved with implementing and forcing into use at a large retailer that has a large square orange logo. That's the three things I'm covering. Nothing more, nothing much less. HashiCorp Packer. So what is this tool? I know almost everybody in this room has used Terraform a bit, but does anybody use Packer?
Oh, yeah.
You have? Okay. So you're probably somewhat familiar with it. It's a very single-use tool. Its sole purpose in life is to make machine images. And when I say machine images, I'm talking, generally speaking, virtual machine style images. It's open source, just like the rest of the HashiCorp tools are. It's cross-platform, written in Go, so across the board, whatever you need it installed on, you can get a native binary for it. It can be integrated easily into your Puppet or Chef or Terraform or whatever tooling that you're using to automate your flow into whatever. The thing Packer does where it saves you tons and tons of time is if you run into a scenario where you're ever making, let's say you spend time making more than 2 images on anything like VirtualBox, GCP, AWS, Windows, Azure, whatever, you should probably step back, take a look at Packer, because you can build your images, make them repeatable, put it into your automated flow, etc., and you don't have to go back through and deal with fighting around customizing your networking or your drive sizes or what type of drives are connected to machines and all that kind of stuff. Packer can do that for you. The use cases for Packer focus around making sure you have dev and prod parity across your continuous delivery environments so that you have the same thing everywhere you look, no matter what you're doing. It's also pretty effective and a little bit less used in this scenario, but for like appliances such as kiosks. Like you go into a place and it just has the screen or whatever. It's easy to bake in an image, make sure it's the same across the board, and then just keep it maintained from that. So it's kind of like you're deploying a read-only image to a kiosk machine that would go into like a Walmart or something like that. And then it's also used pretty regularly among just automation services. Like if you have an enterprise account with HashiCorp, Packer is part of the tooling that you get that can be put into its continuous build cycle. Every time you do a commit to your repos with Packer, it'll automatically build those images, so you always have the latest, greatest image that you've baked in your AWS account or whatever you're using, GCP or whatnot. The perspective that I'm speaking about it from in this presentation is purely from environment parity. That's what we were using it for at the big orange retailer. I'm going to be super impressed if I actually say big orange retailer every single time. And we didn't really use it for anything else but that. We had tons and tons of images that we were building in GCP, and we also built quite a few in AWS. And it saved us tons and tons of time whenever we had to tweak little changes and do things to that. Because then we don't have to go through the full process of building that specific AMI. We can just put it into the queue and let it do its build, and then 5 minutes later or whatever, we have brand new AMIs with the latest, greatest baked into them. So Terraform, everybody's much more familiar with Terraform. It takes a systemic view of all your things, infrastructure, from a networking perspective, from subgroups and DNS, and even domain names in some cases, like if you're doing Route 53 in AWS. All of these things, it'll also build whatever AMIs that you have pre-existing, like say if you built them with Packer, Terraform can use one of those AMIs to build instances from. And it's also written in Go, open source, cross-platform, same as Packer is, follows the same model as all the HashiCorp stuff does, and works against a host of providers, not just the 4 that I have listed right there. In this context, I'm going to speak about it from the idea of doing multi-cloud deployments, and that's one of the things we'll take a look at. I actually have a working repo, which I modernized because when I tried to run it a few days ago, it didn't work anymore, and now it does, so that's cool. And it deploys out to GCP and AWS. The other thing that I want to talk about is how do you use these tools? Sure, you can go to the command line on your workstation or your laptop or whatever, and you can just start poking around and having it build stuff. But where these tools really, really become powerful is when you get it into what I like to call your standard age-old software development workflow, where you have your Terraform files and your Packer files or whatever else in a repo, and you have a workflow around that repo, just like you would with an application development project in Node or Java or .NET or whatever it is. And you have branching for features or additional infrastructure or whatever, and then you commit back to that cycle and you build builds off of that. In the workflow that we had at the large orange retailer, we basically, the main thing we used was GitHub. We also had some internal Git repos, but we had everything primarily out of GitHub. We're using Packer, Terraform, used a lot of bash scripts. We had all of that stuff wired together and working through what was at the time called Atlas, which is now Terraform Enterprise or Packer Enterprise or whatever enterprise thing that they have it named. Basically, it's their SaaS suite of tooling that brings it all together. They use Vault to manage secrets, all your keys, all those types of things, and they do all the builds and all the continuous deployment for you based on this. So if you like infrastructure first builds and deployments, it's a great tool to use, and we had a lot of great success with it from the perspective of we baked our applications into the virtual machines, into the AMIs, and then all of our deployment was done through their services in. So it was all through their web interface. Made it super easy. So big orange retailer. Looks nothing like their actual logo, I'm sure. The thing that we used GitHub for, I just wanted to break out like how we kind of separated out the tools to some degree. The GitHub repos, devs, and ops, I won't even pretend that there was a thing such as DevOps in this organization. There was very clearly defined operations team and very clearly defined development teams. They would generally have access to GitHub and be able to do pull requests, merges, all that kind of thing. So they would actually work through the process on a day-to-day basis. And some technical people, I don't actually remember ever at all what they did, but they were technical enough that they had GitHub access. And every once in a while, they would put in a PR, and 50% of the time it would work. Otherwise, it was very interesting to have them because the other technical people were usually people that were from out, they were like out in stores managing things from very much the customer perspective. So it was interesting to get some of their feedback. I don't know if anybody's used waffle.io, but it's basically kind of like GitHub projects, but it was around way before GitHub projects. And it gives you the Kanban board where you can drag stuff between those. And it does it all with GitHub issues. So whatever you do on the board is reflected in your project. They also have nice little charts, where like burn down charts and all that other stuff that a lot of managers like to see, especially at very, very large corporations. So we used it to provide them a way to look at a repo really quick, and they could look at the README and see these little cute charts and stuff that meant whatever they meant. And they would look at that instead of actually going and looking at the issues list or actually communicating with people. So that was a great way to have them do whatever they were doing. Then we had some read-only AWS and GCP dashboards, which is kind of like the standard thing. You log in and you see this stuff, and it has process power going on, like in GCP, and in AWS it has whatever. But some people would actually go in and look at that stuff and look at the various lists of EC2 instances and things like that. It ranged from people like under the CFO and stuff like that, where they would just go in and they get billing info and things like that. So we got a little bit of interaction from them about, why'd you just deploy something that now is costing us $125,000 a month? I don't know. So that's kind of how that feedback would come from that area. Then we had some static reports. I don't know that much about them because I didn't make the static reports, but I know data went there. And it was largely output parameters off of Terraform and Packer. Like they could get stats off of that, and they could get stats off of Atlas that showed how much usage we were having out of the system. It was kind of interesting. I didn't look at it too much though, since I was mostly in the Terraform files and running stuff, so I knew how much things were running. And then we also had New Relic, which monitored the delivery of the things running through the build process in the HashiCorp interface. And ops and support would mostly look at that. So if something got deployed and then it went down, they'd look in there and they'd start doing back, kind of reverse engineering the problem to determine what happened. Rarely did anything ever go out that didn't already get built in, like a test and a UAT and like 4 other environments. So by the time it went prod, like 99% of the time, all those deployments would be no problem. So that's the primary tooling that we had in place that we worked with around Terraform and Packer. Oh, I should have showed that while I was talking through it. But basically, I broke down what we were doing with GitHub and kind of how, to some degree, different people interacted with it. And the HashiCorp Enterprise, that's where all the final steps were all going through that interface. We attempted to, and this was a lot of, how would you put it? I guess we created some scoping around who should do what in the organization, around writing Terraform this or Terraform that, or writing Packer or whatever. But none of it was like strong enforced. It was kind of like, hey, can your team do this? Cool, we'd love to do that. And then that would be their responsibility. But like the dev team primarily would do Terraform files to create prototype environments, which they could deploy stuff to. And then they would put PRs in of those environments. And then ops would take that and kind of tweak it to make sure that it would work within production. So that's where ops would then come in, and they then had the responsibility of managing the Terraform files and the respective infrastructure that was deployed. And support also used them minimally to kind of attempt to do some testing and kind of do some reverse engineering. That also depended on communication cycles, which made it a little weird. But we tried to scope it out that way so we knew who would be doing what with what type of Terraform project. That's a more complete list of the initial team that I worked with. We were the prototype team for all of the Terraform stuff. Before Terraform, they were using mostly people clicking buttons and things like that, which is pretty cool to go from that to run this and your whole thing runs. We also integrated with all these tools, like some of the stuff I mentioned, GitHub, internal Git stash, but also in addition to, I missed New Relic, but like New Relic we had for external facing data collection around our sites up, our commerce capabilities intact and running correctly. We would check security endpoints and SSH keys and SSL certs, all that kind of stuff, like a whole bunch of stuff. But we also wired it up to Elasticsearch and Elasticsearch beats so that we could get extra internal data collection on all the servers, containers, and servers would be some physical, some virtual machine. the virtual machine stuff was obviously deployed by Terraform, but it was nice to get across the board specs on this because that did all of our data collection. We had tried using Nagios, however to say it, for a while, but that became a super clunky, it falls over a lot and requires servers beyond what we needed to manage anyway type of service. So we moved to Elasticsearch and Elasticbeats, and it worked a lot better. All the data collection was I believe it was 0.01% of processor usage at peak, like when servers were going crazy. The Elasticbeats were super efficient. But also we had some of the things based on how the system would have issues reported would go into Jira, and support used that in some way. So the code that I'm going to show you first is located there. So you can clone it and do whatever you want to it and send me PRs if it doesn't work. What I have set up here, and I will add one caveat before I dive into this too much. Like I said, I dove back into this a week ago or 4 days ago or whatever, after not touching it for like a year, and it didn't really work entirely. So it's in the state of where I repaired it to. But overall, what it used to do was deploy to 2 cloud environments, AWS and GCP, 2 instances in each that it would put behind auto-scale infrastructure. In GCP, it's called 5 different things, but it effectively amounts to a load balancer. And in AWS, it would put it behind a load balancer. I don't have the load balancers recreated, but I have most of the innards of what it needs sitting here. And I also have, you'll notice, a Terraform directory and a Packer directory up at the top. I don't know if I can make, oh yeah, I can't make that bigger, can I? So I hope you can see it. So what I've done is followed somewhat what is defined in the autopilot pattern, something that I believe Joyent kind of put together about a year ago. And the idea is that you have your application code, because you can see down here I have my views, routes, stuff like that. Standard Node.js Express app. Basically is a Hello World app, because that's not really the focus of this. But it is nonetheless a server-side executing Node.js application. Then up here, I have my Packer directory, and I have the definition template, which at the top you can see my accounts.json, which is for my GCP authentication and everything. I have an instance name, so they name the same thing across both AWS and GCP. Same thing with image name and image description. And then I have the builders. This is the key part that defines the AMI and the images in respect to GCP. The top one is for GCP, Google Compute. Very similar in every situation, whether you use an Azure, GCP, AWS, whatever, you're picking basically what amounts to a region, zone, area, location combination, depending on what they name it for their particular cloud, and assigning it to the particular instance image that you want to spool up in your environment. So like for the Amazon EBS, the second one there, you can see I've chosen US West 2, given it an AMI name, instance type, and all that type of thing. And the same thing for the Google Compute. It's in West 1, which I guess is California or whatever, et cetera, et cetera. Those define the starting point, right? The starting image. And then I have the provisioners, which the intent is you break out whether you need shell execution, or like if you're using if you're creating a Windows virtual machine, it would execute, I think it's called WinRM or whatever, that terminal to execute installations and things like that. You can execute all those types of things here. They have all sorts of types of provisioners that you can execute against the particular base images. And these, for me, I just have, it's super straightforward. It's just shell scripts that run. I have 2 specific ones. The first little entry you'll see is file, which literally copies from the source to the destination, which means the local repo to the image once it creates it, right? Pretty straightforward process there. And then the next thing is just a shell execution of that script. And I have a pause right before it because things don't like to run super fast right after creation. So I give it a few seconds just to make sure that it's done doing its starting.
Do these run in parallel or are they sequential?
These are sequential.
Okay.
And yeah, I very specifically have it in sequential order here. Well, these aren't specific. They don't need to be sequential. But I did at one point, I had like the Node.js would install, and then I would install some dependencies that needed Node.js installed first. And then I would set up the firewall after it's done pulling all this stuff off the internet or whatever. However, it is good to note that it executes provisioners in order in this context, but Packer does make decisions about what it can execute in parallel, and it will do things like that. Just like Terraform decides, like, some things need to happen in sequential order, obviously, because you need A before B, but if it can execute two things at once, it'll do that, right? It'll drop out and do concurrent processing of that. So that's the Packer script, or the Packer template file.
Really quickly,
Yeah.
Packer can target AWS and Google Cloud Compute. What other things can it target besides those two entities?
VirtualBox, VMware in the cloud, VMware on your local machine. I forget how many there are, but it can do a number of them. The only one that I've ever had any significant issue with is Rackspace, but I don't know if Rackspace works 90% of the time. So that's a little iffy. But like it does Rackspace's open source thing too, OpenStack. So it's got a builder for almost every single major virtual machine, anything out there. It does like the open source ones too, like Zen and some of the other ones.
Can it build Raspberry Pi images?
What Pi images?
Raspberry Pi images?
Yeah,
Curious.
I'm not going to say no, but I don't know if it does. It seems like a perfectly good use case. So yeah, the way you run that real quick is just Packer build, and then I do force because I just wanted to recreate over the images, and then you pass it the file. Am I even in the directory? I'm in the directory. So yeah, Packer build force Node.js. Oh, there it is. And it'll go through the process. And you can see where it starts to interline things here in just a second. See, it popped up the Amazon EBS one. It's waiting for it to go and the GCP one at the same time. So like it's actually running both of those. And you're just getting the feedback as soon as it gets that done message or whatever from whatever it's running, whether it's the GCP image or the AWS image. So that takes like 6 billion hours. And I know the AWS one fails right now on the shell creation, but it will create the instances. And just to talk about real quick before I move to Terraform, what Packer does, if you've ever created an AMI or GCP image, you know it's a complete pain in the neck. Because you go and start an instance, then you put stuff on it, and then you have to shut down the instance, and then you have to make a backup or a copy or whatever it calls it in whatever cloud provider of the disk. Then you have to delete the instance so you can disconnect the disk from the instance. Then you have to delete that disk. Then you have to take that copy or that backup or whatever they call it and make it a disk again. And then you have to take the disk and turn it into an image. There's like this really weird, tedious, time-consuming process. And that's all the stuff that Packer does, is it goes through all those ridiculous steps and all those like, performances around, I need to spool up the SSH, I need to create a security group, and I need to create a key, and da-da-da. It does all that, wipes them all out, cleans it up, and then all you're left with is just the image that you want. So that's where it'd take you like an hour to get a stupid builder and everything wired up exactly the way you want it. But by the time you're done doing that once for that hour, the next like 5 times you need that AMI updated, you easily save an hour worth of time not fighting through the whole process of manually creating an AMI.
That's awesome.
So, yeah, it's pretty cool. So, and see, there it is cleaning up the GCP instance already.
It was on the trail behind.
I forgot those stupid shortcut keys. Oh, there's that SSH thing. The problem with using too many OSs is you end up learning too many shortcut keys for things, and then they don't work half the time. So we'll assume I've already created image with Packer, whatever, those exist. And then with Terraform, what it needs to do is basically take this zip right here, or this tar file called brood application, and it needs to put it into the instance and then deploy it, right? So it basically takes the Packer created image, makes this final step of putting the application on it, and then spools it up. And that's done with Terraform. Gotta be in the directory. First thing you want to do is Terraform plan. See if everything's all up to snuff. So there's all of the items it will build. And yeah, see there you can see the AWS instances summarized, all the Google compute stuff summarized, etc. For the AWS stuff, I'm putting it into I'm going to talk about this just for a second, mainly because I have had to fight with it because I have a freakish Amazon account because it's old. I created a default VPC, which I guess everybody else on Earth has except me. And I put the Terraform files for creating this default VPC in here. It's got the roots, security groups, all that kind of jazz in there. But it's basically the default VPC that you get if you start an Amazon account today, right? So if you've started one in the last probably 2 or 3 years, I think you have a default VPC, and that is assumed to exist. And then if I run that, it'll start executing stuff. In this repo, you'll see terraform.tfstate and terraform.tfstate.backup. That basically takes the before and after state image and backs it up and documents where it's going to go, like the before and after, in the sense of this is what it's going to attempt to do. And then whatever it does accomplish, it'll write the things it accomplished into the tfstate file. And basically it looks like this. It's actually readable. It's just normal JSON. There we go. So and it's tracking everything that it's putting out there, like the server instance, where it's at here in the availability zone, et cetera, et cetera. And it actually puts like the public private IPs, things like that, so that whenever you run it in the future, it knows where to remap things back to if it has to delete things or just recreate them or whatever it has to do with them. This is something you shouldn't have to go digging around in, really, but sometimes it's helpful to go look at it and see what exactly is going on.
So I have a question for you.
Yeah.
So you're an orange retailer. How do you guys keep your state? You keep it in S3?
Well, that's exactly what I was going to tell you next. So initially when we started out, we were putting it in the repo because it was like, oh, everybody can share it. It's in the repo. But that gets super flaky instantly because the minute anybody grabs it, does a plan or an apply, and then commits their stuff back, the next person that gets it is now like, well, that's not where any of my stuff was. So it's got this like weird mismatch that starts to happen. So what you want to do is you want it to be in a place like S3, which I believe that's where we're putting it now, right, with the rise up stuff.
Yeah.
At the Orange Retailer, we put it in the Atlas solution because that's it ends up, I guess they actually put it in their Vault solution. So it's like super extra duper encrypted.
It actually does lock in, right? So no one else can actually.
Right. So the thing.
There's an S3 solution that does the same thing for free.
Yeah, exactly.
Really? Oh yeah, I've heard about that one.
Yeah, so you can do it with S3.
Run something like that.
Is that what it's called?
No, it's just an S3 bucket and
Just push it
a
up.
DynamoDB table that is through your locking mechanism.
Yeah.
Okay.
And you can
I heard about that.
you can change the points that it does this, and you can pull it back with the Terraform command. It's like Terraform, I forget exactly what, like publish state or something like that.
Terraform state question.
Yeah, that. So you push it up to the thing you want it to be responsible for it to manage that now, and then if you need to move it, which is one of the things I ran into, because at first we were doing it this way, and then we put it in S3, but then the large orange retailer decided, oh, we're not doing AWS, which is part of the kicker of this and the reason why we were going multi-cloud. But we had to pull it back out, which was a little weird at first because I was like, wait a second, it's there. How do you pull it back out? They're like, oh, you just like pull it and then push it back over there. It's like, oh my God, it's like a Git repo. So that's what we did. We ended up pulling it back down. We put it in the repo, and then we re-pushed it back up to the enterprise solution now that they have, which was Atlas. But yeah, the reason that we were doing this wasn't because we were worried about one of the clouds going down. They were both perfectly reliable as far as we were concerned. If we were going to do anything, we were just going to go multi-region in a cloud provider. But when I started working for them on this particular project to scope out all this stuff, they were super indecisive. They were like, well, we don't know if we're going to go with AWS or GCP or Azure or, X provider of things. So when I sat down to look at how to scale them up and get this out to everybody at the company, I was like, well, I got to be able to work with all of the cloud providers. I can't just do one and then hope that that's going to bake across every other provider instantly the minute they decide to not use the one I just worked with. So I looked at Terraform and it was like, oh, this is an obvious choice. I can work and build stuff for every single one of them. Just like with the Packer file, both providers are in a file. So most of the file ends up being just one statement of like, run these things, do this stuff. It needs to be here. This needs to be there. And the AMI and base image are the only thing that are different. So that helps.
I have something to contribute to that too. One problem is even if you have remote state, it's a problem that's kind of fundamental. I experienced on a couple other clients where if you try to say, we want multiple people to work on this stuff at once, right? Somebody's working on adding a database or something, and someone else is working on setting up some GNet stuff. The reality is, there's only one real state of the world out there, right? Those are the instances that are created. Those are the resources that you're using. And in something like Terraform, what's going to happen is it's going to diff what you want with what's out there, right? And it's going to drop anything that isn't in your list of stuff I want. When two people are working on it at once, what happens is you're going to get the race condition, people stepping on each other's toes and resources getting dropped. And I think a lot of people's first jump to that is like, oh, well, what about branches? Branches can solve that problem, right? That's how we do it in code. Unless the physical resources that you end up with are matched differently based off the branch you're on. For example, if you imagine having all your servers be master dash something, and then you branch for adding a new feature, and then when you spin it up, it's that feature dash. Or you have separate copies, right? When I'm adding a new feature, I copy what's out there, add my stuff, and then merge that back in. There's really, at a fundamental level, if you're going to have one source of truth, which is a cloud provider, and a definition of what you want in that cloud provider, you're going to naturally have that race condition. So you kind of have to do the same thing you do if you want to avoid mutability problems, is you have to make it immutable. So you have to create a copy.
Well, that was what the master, effectively the master branch became in that enterprise Atlas solution, was when if anything went to that branch and it got committed into there and you pushed it up there or whatever, it would run, period, right? That was the trigger. What we would do when we needed to work on it independently was we would branch it, and we actually ended up with like this secondary thing that would still either not execute or execute a build, but it did like this build that was just the plan, and that was it. And so you could do a certain amount of things, but you run into very serious mutability issues that you don't in a general web application environment because of exactly what you're talking about, where you have that one source of truth, which is the reality of production. But having that Terraform plan build at least gets you part of the way of, well, I'm working on this other thing, and I actually want to at least make sure it validates and will run against theoretically what I think it is, even though I'm off in a branch. So we would have those builds too, and they were, I don't know, I guess I'd say 50% of the time they were pretty useful. You could at least do some work before you try to shove a PR back in. But at the end of the day, you have to get it back in there and look at the plan on that to really get it to reflect against what's going on. So let's see here. Where did our build go? Oh, look, that was completely successful. Awesome, just like it was an hour ago. Repeatability. It's a really awesome feature of technology when it works right. So if we go back over to the Pretty interface, you can see both of those instances are running along with my other random thing that was running. Over here, you can actually see Broodbox image, which is the image that Packer made that the Terraform project used to build those two instances. Now, if I go over here and I look in the correct place, the two instances should be there too. Yep, so there's those two running. So I literally have all four of those instances deployed out to two environments. Terraform is a bit different too, and there's a lot of similarities, but there's still a bit difference in how you set up the authentication. Like here, I have the account.json, which it points to for authentication with GCP. With Amazon, though, in this particular case, you don't see anything set because I'm letting it just use the default credentials, which is the .aws/credentials file that you either set up yourself or like the CLI, when you install the AWS CLI, it'll set it up. Certain things will set it up for you. All that effectively has in it is your region and your key and secret key thing combination, and that's it. With Google Compute, it's the account.json file, which is basically what they call a, I'm completely forgetting. Basically, it's a special account that has the ability to just build environmental stuff. Like, you don't really use it for anything else but to build out the environment, to run effectively service type stuff. It's kind of like a service account with a little bit more horsepower. And anyway, that's in a file, as you can see, like right here, and that's all Packer does to get that verification information. In Terraform, I like to create a connection.tf file and put whatever I need to in it. And in this, it's basically the same case. AWS, since I'm using the AWS/credentials file, all I have to do is designate the region. I believe you can even set the region via file too, so you don't even have to put anything in here except provider, AWS. And then whenever you're doing any AWS resources, it uses that connection. For the Google, the connection again is the account.json. And then you have to select the project, which is a proprietary GCP type of thing, which aligns to a particular billing model or whatever that accountants can handle and get reports from. And then region is the same as the way AWS works. So and then everything that is getting built in GCP gets built and deployed to that particular connection. So that is pretty much it for my multi-cloud deployment demo breakout of what we did for that particular situation. And then when they decided that they weren't going to use AWS, I didn't care because I had it working in two places, and one of them happened to be their choice, which was GCP, and I instantly already had all that stuff working because I built it to work in both places.
Did you do anything to try to set up like a load balancer or anything that would, you get one request coming in and then it decides some of my traffic's going to go to AWS and some of it's going to go to Google?
Yes, and it wasn't terraformed because it was sitting in some monster F5 load balancer that, yeah.
You said
I
it
don't-
once manually, basically.
Yeah, happy to talk about that off camera. It was a special F5 load balancing scenario that was very corporate. Let's just put it that way. They could have load balanced the freaking internet with that thing, but it just had like a little bit of traffic going to it, and it split it between respective environments. And it did take 3 months to get the settings in there to say that there was going to be 3 different environments that Terraform was going to deploy. It was super epic. It worked though.
Cool. I mean, it's cool that it worked.
Yeah. I do wish that it would have been much easier and it would have been totally feasible to just set up a load balancer via Terraform and one of the providers
Sure.
that just said split traffic to these things.
Yeah.
But we did it that way just because enterprise diagrams said we should do it that way. So we were like, all right, whatever, we'll follow that rule. We're going to break 15 others, so we should balance it out a little bit. So, cool. Thanks for listening. Any other questions, throw them at me. Or at the room, for that matter.
Your TF file specifies that Google and Amazon
Mhm.
one TF file, right? So the
Yeah.
resource.
Yeah, and I just followed. So the idea of making a connection.tf, I'll admit, is just like something that I yanked right out of doing Java and .NET. It's like you end up with a database connection file that just has the connection string in it or whatever. And I had done that so many times, I was like, whatever, I'll just make one for Terraform. It seems to make sense. And then I just put all my whatever I'm connecting to, I just put in there. Seems like a logical place to put it.
It works out for AWS too. If you just have this and you want to programmatically switch your state from local to remote, like you have a controller that's outside, like we have one for one of our projects that's a bash script. It says if we can check and see if there is a remote state existing, use it. Otherwise, use local state. In order to make that work, you have to like rename the file so that Terraform doesn't pick it up
Mm-hmm.
in one of the situations. But that only works if only the provider information is in that file and nothing else.
Yeah. What was the question you were asking me about modules? You want to repeat that for everybody? And there might be more input besides just what I was saying.
So,
The best practice is to reuse modules, right? You write the modules, different
Yeah.
applications,
Just like where
are
are we
using those modules, those variables, right? Let's say they need it on a load balancer, right? So they'll be using that instead of rewriting their own in their own application.
Did you have?
Sorry, I missed the question.
Yeah.
We use modules. Sorry, I missed the original question.
So let's say you have, and best practice is you actually write a module so other teams and other applications can use it, right?
Right,
So that's
right.
a variable, right? And so, do you write them? One of my managers right now is like, well, do we write a module for just load balancer? Or do we actually write a module for an application?
Yeah, I have a vision for that. So, I have seen very few environments where you have homogeneous applications where this one looks the exact same as that one, and it's why when we like use technologies like Docker, it's like so powerful because it's taking what isn't homogeneous, right? Some applications are written in C, some of them are written in Java, some are written in Ruby or Python or whatever, but they all go in the same kind of box, so I can deploy them in the same way, right? So that sort of makes it so that each platform doesn't have their own deployment mechanism. It's kind of the same thing as that, in my mind, when it comes to Terraform, is that if you try to say, well, here is a module for an application, you're going to get into a lot of hairy situations, because what's going to happen is every application is going to be a little bit different. What if that application needs a Postgres database and this one needs a MySQL database? And now maybe you're going to say, I'm going to have a parameter in there that says Postgres or MySQL, right? The number of parameters and options becomes very complex over time.
Right.
So what you actually want to do is, like, if you think about it in OO, you have like an inheritance model, right? and you can derive. And that's kind of what maybe that application would look like. You're deriving and incorporating all these pieces into one package. And then I think it's better to think about it in terms of composability. So lots of pieces that can be put together in a pretty sane way that doesn't dictate all the other pieces, right? So in like OO world, that would be like class composition versus inheritance, right? And so in that specific example, I would say yes to the load balancer, like maybe have a module for a load balancer, but not for this is what an app looks like, unless you truly have a homogeneous environment.
Even if you do, don't go down that route because it will lock you into you have to forever have a homogeneous environment or your stuff isn't going to work.
So there's one other caveat to that is that if you end up in a situation where you have a module with like one resource in it, or maybe two resources in it, it's probably a sign that you shouldn't have a module for it. So there's actually a project I'm working on where I'm thinking about pulling a load balancer out into a module, but it's like, well, actually the load balancer is the only thing in there. All the parameters are going to be which ports do I want to forward to what, and do I want SSL certificates and stuff like that. Why create my own specification for the same thing that Terraform already has? But if you're in a situation where I need to set up a load balancer, an auto-scaling group that's set up to connect to that, and a DNS record for it, well, that's kind of a composition of things that maybe is valuable as a unit. But like, just be careful about going a little bit too far with just wrapping what already is.
Don't go into overloaded constructor hell.
Yeah.
Basically.
Yeah,
I was just going to say, just thinking of that too, one of the things in GCP that I thought was kind of trippy was when I first started working with Terraform in GCP. If you go into GCP and you want a load balancer, you click in the load balancer section, right? Seems super easy. But then as soon as you create this, you start realizing you have a lot of different options, right? But basically, you tend to have a particular load balancer type you want on a regular basis in GCP. Like if you want 3 instances behind something. If you look at the Terraform, there's like 5 different resources to make a load balancer. You don't want to add all 5 of them every single time you want a load balancer. So you can modularize a lot of that and compose it to just say, oh, I want a HTTPS load balancer across da-da-da. And that's all you want to say. You don't need to say, what are my instances? What distribution group are they over? What is the routing? You don't want to have to like add all that stuff all the time. That stuff needs to be done anyway. So like you can turn that into a module and just say like, the instances I just created need to be in a load balancer. Like two parameters basically. And if you turn that into a module, then it says, oh, okay, you need this thing, and this thing, and now wire it all up and dynamically allocate the IPs to route to that stuff. And then you end up with like this much of a snippet versus the 5 pieces of the GCP load balancer.
Another just sort of kind of gotcha thing to kind of keep in mind as you start using more modules is that be very careful to enforce that the only way that something could be done is through a module, right? So if you create a module, let it output the things that you would need and be able to create on your own, such that using the module is a convenience thing if it is something that you're going to replicate a lot of times. But when it's like time to do something a little bit more custom, where you need to support HTTPS and HTTP as an example, or a different port besides 443 or something along those lines, you can break out of it and the entire system isn't broken, right? You want it to be you're taking out just that one piece and replacing it with something custom.
Yeah.
And it's very easy to do that wrong.
Yeah.
You have to be deliberate about it.
Focus on being generative, not restrictive. Right?
Yeah. I have to check.
Cool. Thanks, everybody.